So I'm going to hand it over to Addy, who is our moderator.
Hello.
And we'll have a great session. Then we're going to do some Q&A, right?
Yes.
All
thanks.
right. Take it away.
All right. Thanks, Lori. Hey, everyone. Welcome. We are really excited to talk to you about the future of motion capture in the era of virtual production. It's a mouthful, but that's what's happening. My name's Addy. I am with Disguise.
My name's Niall. I look after partnerships at Move.ai.
I'm Ray Fisher, pronoun she, her. I'm with Netflix Animation, and I am a longtime user of Mocap. So I'm representing all you Mocap users out there with
Awesome.
these guys.
I think all of us have had at least a decade or so time with traditional motion capture, so we could speak intelligently to you about what we have been doing, and then we'll turn it over to Niall to speak on the future of motion capture.
Definitely. Thank you, Addy. And again, thank you both for joining the panel. I couldn't be in more esteemed company, so I feel very lucky to be here, being the startup upstart that we are. As Addy mentioned, given the experience that both Ria and Addy have, what we wanted to do is dive into the problem of trying to recreate human motion, how to do that, and the pathways that have already been taken to do it. So ultimately, creating lifelike movement is very hard. And recreating that effectively
incredibly hard, as Ria knows, in animation. And I worked at DreamWorks for a long time. So the rule of thumb was 3 frames a week for animating lifelike motion. So imagine that a movie is 90 minutes times 24 frames, and that's just one character. So fast forward to motion capture being a quick solution to provide that lifelike motion. Well, it wasn't so painless, as you could see from the pictures here. The suits, the markers, the cameras, the solve algorithm, the time it takes to
The guys in
it.
white lab coats all around you.
Yes, I was one of those guys.
And you look good in a lab coat.
Yeah, so this is the world that we come from.
Absolutely. And what we want to dive into is the space for motion capture, the need for it, and also dive in a bit to AI, right? Like Move.ai, we are an AI company, but what I want to do as well is, whilst leaning on the massive experience that we've got here on stage, is actually talk about, as what I think has been really inspirational actually and very interesting to see over the last couple of days, is people demystifying the use of AI and technology and how it can be used in production workflows. So we really want to dive into that a bit and then look into the future a bit as to how AI can help the creative process, but also what else you can do with it. So I'm going to dive into AI tools a bit as well. But to go into, let's call traditional motion capture and performance, fundamentally,
From the old days.
from the old days. I mean, but I see the old days. If you look around the studio right now, there is a Vicon system there. There looks like an OptiTrack system there. Mocap has a place, right? Mocap has a place, and optical tracking systems have a place for several reasons. And I think ultimately, from your perspective and the experience you've got, where going from the early days of Mocap to where it is now, in terms of the progression that you've seen in like
Oh,
technology.
Niall, you don't know who you're asking here. I wrote
That's why we've got 50 minutes.
all right, you all ready? I wrote a chapter in a book that was supposed to be published by Springer Verlag, all about the history of motion capture. And I went back into the 1930s when they were using synchronized film cameras to do motion studies. And I'm going to skip way forward so that nobody catches up on any sleep right now. But the point being that motion capture has a long history, and it came out of biomechanics and the study of human motion. And it was used in places where the expense of doing it made sense. So that's kind of an important thing, especially in the context of what Move.ai is doing, because they have made it so easy to do motion capture, and I am not just selling it. I'm going to tell you why. But it's a long history, and there have been so many different technologies used to do motion capture. Back in the 1990s, we used magnetic motion capture. We had a giant cube that weighed about 75 pounds, and it had 3 windings, and it created a varying magnetic field, and you had little sensors, and you had basically a spine that came off the back of you that looked like you were some sort of, Cretaceous dinosaur, and that was all the data coming off of you. And now, of course, it's so easy. But optical motion capture, a couple things that are really important about motion capture. Quickly, point to Addy. First of all, motion capture produces puppeteering. It doesn't really produce animation. Let me be clear about that. We'll call it animation. It's movement, but it is puppeteering. And one of the key qualities of that is that it's extremely challenging to edit, because when you capture a full body of movement, every little micro twitch that you do, every little casual movement, every little thing that you do is countered by a contrapposto sort of, counter movement and things like that. And if you have an animator who traditionally is doing emotion motivated movement, that is completely different. That's animation, right? So this is puppeteering and this is realistic motion. It absolutely is important and has a place, but these are some basic things. Anyway, let me just say the history of mocap technology, key things to remember. You've got inertial motion capture, like the XN suits or Rococo or all those things. Important thing about those is that's relative movement. So if I start walking here and I walk to the end of the room and I come back, there'll be like an error that builds up, right? If you use an optical motion capture system like this, you get what's called global accuracy, right? If I put my foot down in a spot here and I motion capture it, walk away, come back, it's going to be in pretty much exactly the same space. But I have issues that I don't have, like I have optical occlusion issues and things with optical mocap that I don't have with magnetic or even mechanical motion capture. Those systems were fun. You guys ever play with mechanical? It's like you're wearing a bicycle.
Is it all resistors and stuff?
Yeah, it's all, well, it started out resistors and then it became optical encoders and stuff. All right, and that ends our lesson in motion capture history. Hope you enjoyed it.
I think you'll all agree that was hugely insightful. And so ultimately, I think we saw a lot of acceleration, I think, in the public sphere. I mean, in this part of the world, motion capture's been around for a long time, but where we really saw an understanding of what motion capture is and what performance capture could be was a lot of the work that was done around the work that Andy Serkis and the Imaginarium did with the Lord of the Rings films in particular. And I know we've spoken particularly quite a lot about this in terms of like technology meeting the need of the creative vision. And this, I think, was one of the first times where that translated into how the general public understood what that actually meant. Is that fair to say?
Exactly. Yeah, so this is the moment where the Mandalorian sort of put VP into the sphere of everybody. Same thing. Weta, Lord of the Rings, mocap was now a thing that the public associated with VFX. So the reason that I use mocap here is because Gollum was a humanoid character and he had to have looked real. So again, all those things Rhea mentioned, when we move our skeleton a certain way, there's a certain counter action, a certain counterweight that we also infer on our skeleton. And those things are really hard to animate. And they're really hard to animate over many, many, many frames and keep consistent. So motion capture in this case is the perfect use case for Gollum, and that's exactly how it was used.
And then also, like, moving forward, I think, and in terms of, again, saying about how different motion capture technologies have their place before we start diving into AI and how that works, as we saw very recently, like the Avatar Way of the Water production could only be achieved with next generation motion capture techniques. I mean, underwater mocap, very, very difficult, right?
Pressurized cameras so that if there was a leak, only air would come out.
And instead of infrared, it was cyan.
Yeah, because that's what transmits through water.
Yep.
You had to recalculate the lens distortion against the flat plane that was separating the air inside the camera case from the outside.
Incredible. And Babek built those cameras.
Yeah, Babek is great. What's this? It used to be Standard Deviation. What's this company called?
So he was acquired by Rockstar Games. Yes.
And so, from a Move.ai perspective, what we are bringing to the market is AI-powered motion capture using video. Now, before we dive into that, I mean, traditionally, so Addy, you were an early adopter of a lot of AI and video-based motion capture tools. Now, is it fair to say across the board there's been a healthy degree of skepticism as to whether or not video-based mocap could ever be a thing?
Oh, 100%, 100%. I think just like when optical mocap was a new thing from mechanical mocap, in the same way, as we progressed into AI-based video mocap, they're like, this is never going to work. And when we first saw the data from Move.ai in early 2020 for Fathead, that was the first project that commercially used it. We're like, oh my God, this is totally good, totally usable.
Yeah, but like, so I'm going to brief trip back to history again, I know, bear with me. It was like early uses of mocap, aside from biomechanics, was also capturing massive amounts of motion for like baseball games, right? Or basketball games or something, where it was like, I wanted to have accurate motion. So somebody looked at it and said, oh, that's my favorite baseball player or basketball player. None of the names of which I'm going to be able to recite for you because unfortunately I'm not into team sports, but you get
Yeah.
Funnily enough, that's how I stumbled across motion capture, right? So my background is actually in sports tracking, live sports, live broadcast. One of my colleagues, Anas here, is actually looks after a lot of our real-time products, which we're going to get into shortly, is also from the same background, where fundamentally you're deploying cameras across large volumes to try and understand the movement of individuals within that sport, to extract things like data, to extract things like insights for things such as broadcast analytics, for things like betting and things like spatio-temporal analysis, where we then I was then introduced to Move.ai actually by FIFA, the global soccer body, who wanted to, and Major League Baseball, who wanted to understand skeletal positions for things such as officiating. So looking at things like when you pitch a ball in baseball, when your foot leaves the ground, that's when the play starts, right? Things like when you are offside in a game of soccer, that's when the ball gets connected and the last person's, let's not go into the offside rule, but basically they need skeletal tracking to work it out. And I was introduced to Move.ai as a result of that, trying to solve that problem.
Yeah, but come with me now to look at it from the viewpoint of the producer. Again, the boring viewpoint here, which is why does Mocap make sense in these situations? Because at the time, in the past, it had a very high setup cost, right? Remember all those people in white lab coats, right? Yep. That was, it's expensive to set it up, but the thing is, if you're going to capture 500 movements of baseball, it makes perfect economic sense, because to hire animators to do that.
And also, if you have a baseball superstar coming through the door, you better make sure you get all of that.
Oh, absolutely. And that's one of the weirdest things about Mocap is like when you start to work with it and you see just the little skeleton moving around, you say, oh, that's George, or that's Jane, or whoever it is, because you can really tell from
no, that's LeBron James. That's his data.
Thank you for name dropping. I couldn't possibly. That's also why, companies like the CIA are actually doing things like they're doing biometric recognition of individuals from like walking data. But that's a little bit outside of our chat.
We might get into that.
We're going to cover that end of this.
Oh my God, what am I a part of?
We're about to find out. But actually looping into that and actually going into the subject of this particular summit and artificial intelligence, where compared to inertial, optical, definitely compared to mechanical, where Move.ai actually came from was actually a sports background initially, and trying to understand people moving in video for things such as virtual advertising and actually keying them out, and or things like spatio-temporal analysis, etc. What we found was that market's very difficult to get into for a startup, and COVID really shot us in the foot with that one. However, what we were very fortunate in that we had a number of very forward-thinking contacts in the industry who actually went, if you can do this, this actually could be a thing. So we set about building a markerless motion capture tool using artificial intelligence.
This is the cool part.
However, I'm going to make a statement here. AI alone does not a product make.
Do you want me to repeat that?
Please do.
AI alone does not make a product. AI is not the magic bullet.
AI is not the magic bullet. The hard work and productization of microservices around AI and building a tech stack around what is a fundamental core piece of technology is how you actually build on top of artificial intelligence.
There's definitely wisdom you can take out of here, is that AI is not everything. Yeah.
AI is not everything. AI is excellent, and don't get me wrong, I'm a big believer in practical uses for AI, and that's what I'm going to dive into right now in a little bit of a how does Move.ai work? And I will bring this to life with pictures in a second. But fundamentally, this is our pipeline, right? We use multiple cameras or single cameras that can be synchronized and then run into a pose estimator that looks at what human body is. That then is combined with a number of different sources, things like kinematics, which Addy's going to speak to, rigid body dynamics, which all then go through a probabilistic estimator and then spits out a temporal description of degrees of freedom of the kinematic model. All that goes... What?
I think they're catching up on their sleep now, Neil.
Good. It's just after lunch, so I thought I'd do a science lesson. AI and computer vision are that bit. Machine learning is that bit. The overall infrastructure is actually made up of a bunch of different components that come together to then, to Ria's point, reconstruct an animation to be as lifelike as possible that can then puppeteer different character animations or characters. Now, hopefully this plays. So how does the AI actually work? We look for a human body in video, either from a single angle or multiple angles of video. For those of you who are interested in my colleague Jack's dancing, if you were to put on the Weather Girls song, It's Raining Men, right now, you might find that you are in perfect sync with Jack's dance. But what we do is we use that data, the 2D key points. We look for joints, right? We look for shoulders, we look for knees, we look for elbows, we look for wrists and feet, etc. What we then do is we stitch that together. So the key point data from each camera is then stitched together from these multiple angles. We then run that through a kinematic model that I'm going to lean on Addy for in a second. Once we then actually apply that, what happens is you get the key point data and you amalgamate that data from all the angles. What you then do is you constrain it to what a human body is capable of. So for instance, there's a thing called holonomic constraints in the joints. My elbow will only go this far in terms of extension, and there's a double jointed person in the room.
I know,
Always a double
we dealt
jointed
with that,
person in
yeah.
the room. No, you are really bad for our model. But fundamentally, at a certain point, that would break my arm, right? We constrain that body data to adhere to what the human body is capable of. And then we also actually apply kinematics to that. And in terms of the kinematics, Addy, in terms of how important that is to be able to apply human IK to an animation output or a mocap output, could you?
Yeah, absolutely. So kinematics, sometimes called HIK, sometimes referred to as human inverse kinematics. It's a mathematical model of our skeleton. So one thing all of us have in common in this room is we have the same skeletal structure. Now, our bone lengths might be different, density and width might be different, but we have the same type of structure. So we can put that in a mathematical model. Like Niall said, our elbows only bend this much to this much and so on. And this incredible model can then be the basis of your solver. So when you get data from, let's say, your wrist, you know that your wrist is going to be connected to your elbow is going to be connected to your shoulder is rotating on your clavicle, and so on and so forth. Actually, all of us mocap people are biology experts because it just kind of comes with the territory. So the markers are strategically placed on end effectors, so where, you know, those things are affected and the kinematics can be driven from. That kinematic model comes from traditional optical mocap, but it perfectly, because it's a mathematical model, applies right into markerless mocap.
100%. And actually then what we do is we apply a physics model to that data. So we actually apply the laws of gravity to the inertia of the limbs and both the rotation of the limbs and the forces upon them. What that then does is it gets a really, really accurate representation of what that person has done, right? But again, that's data alone. To Ria's point earlier, your next challenge is driving a character with that data, which, in terms of retargeting, is incredibly hard.
Yeah, because this is one of the things that people don't realize about mocap is that when you capture motion, you're capturing an actor, but the actor is not what you usually see, unless, as in my case, like when I worked on it, Tom Hanks is playing Tom Hanks in Polar Express.
It's
right?
like the 1% use case.
Yeah, but when Tom Hanks plays the 7-year-old boy, you have to do things like correct the facial marker data for jowl sag when he turns his head. There's all kinds of things that happen between the source and the target.
And what you can see as well is that within that workflow as well, it's fair to say as well, if that retarget's not done very well, that can actually propagate what you would call noise or what would look like poor data through the entire animation, right?
And up until now, I think a lot of the retargeting is manual. So you literally point, you know, left shoulder of your source to left shoulder of your target, and you do this bone by bone by bone. And then if you have 52 bones, that's one character, and then you have 10 characters. So you can imagine how much human intervention is needed to retarget. That's done in Motion Builder, even Unreal Engine, until now, right?
Yeah, there's like in extreme cases, you'd even do things like you'll map, like we did in Beowulf, you'll map an actor onto a dragon or something completely different.
Right. It's a whole different target. Yeah.
And then ultimately, what we wanted to get to as a company in terms of getting this feedback from the market was that is a marker-based mocap ever going to be replaced? Maybe, maybe not. But can video-based, AI-based motion capture be as good as optical? Well, this time last year, we were fortunate enough to come to SIGGRAPH, actually in Vancouver, with Electronic Arts, who put our system through its paces. You can see in this test here, we have a person wearing both an X-Sense suit and being tracked by Vicon. The X-Sense actually failed because of the amount of metal that was in the stadium and in the studio. But this is actually 75 optical cameras, 53 reflective markers on the human body being tracked by the optical system, and 8 GoPro Hero 8s tracking in the Move system. So when we got to this level with one customer, we were like, oh, okay, this could be a thing.
I mean, it doesn't seem mind-blowing, but just having touched a lot of sweaty people over the last 10 years and changed markers out, I could tell you there was no markers or sweat involved in the Move.ai solve.
I reckon people on this stage have. Has anyone here worn a Mocap suit? Yeah.
Yeah, well, you have. Yes.
How?
I've seen you in one. Yes.
How cool?
Yes. Yeah.
Yeah.
One of our actors from my last stage is right there. Yes. Hi, Catherine. Yeah.
Yeah, it's so tricky. It's like when we were shooting Beowulf and Angelina Jolie was there. Sean Penn came on set briefly, and he came at lunchtime and he was joking around with us like, "Oh, don't touch your markers. You'll get you'll get hand oil on your retroreflective markers, and they won't work." And he knew that, which shocked the hell out of me. But I mean, it was
Right.
true.
It's true. Yeah.
That's a mocap joke.
So here is some mocap economics for those of you who care. We have to put about 60, 65 markers on a person, and each one of those markers is $3. And you could probably use them a few times and throw them away. So there you go.
But that's still really cheap, right? That's
Right.
that's another interesting thing.
Yeah.
But like completely suitless capture.
Yeah.
I mean, you could just walk into the volume as
Yeah.
long as you're not wearing a lovely flowy cape or something.
You could walk into the volume. You could walk into the V&A in London. So we did a project with the University of Arts London where they actually did a full in-person experience being captured actually on iPhones, and then actually had the data retargeted to this cloth sim as part of the V&A exhibition. Or we have an advertising agency in Brazil who were able just to set it up in a meeting room in their office. Speaking of which, Ria, how easy was it for you to set it up?
Yeah, we were kind of, to say we were astonished is kind of understating it. We were using motion capture primarily, well, I'm gonna go back to animators now, and how animators start out by looking at themselves in a mirror. And you draw.
Don't get me started on animators. Yeah, but keep going.
In a good way, you have bad stories?
Both.
Dish,
Yeah,
honey,
both.
come on.
We've got time. Go on.
Yeah. After, maybe after.
All right, okay. No, there's, like when an animator draws a character, very often for reference, they will have a mirror at their desk and they'll look at the mirror and they'll make an expression. You can see plenty of examples of this online, going back to the 40s and 50s and things like that. And you can, in a sense, think of motion capture or facial or performance capture in general as an advanced version of that as a reference for animators. So like something that we do nowadays, if you have a person doing the voiceover for an animated character, they will sit in the recording booth and they will have 2 or 3 video cameras looking at them, because as they perform, they're gonna do all their expressions and everything. And that's useful for the animator to know. And so we said, if we do scratch audio, like for animation, and we capture video, and we've got this system that makes it so damn easy to capture animation, why don't we just let people run around in the room and we'll just capture motion while we're at it?
I'm just going to quote Adam Meyer from Real Effects, who just said it the best. Animators are just really shy actors. That's what they want to perform, and they want to capture that performance in a bottle and then put it out on screen.
It's so true, and that's another great thing you can take away from this meeting, is that the animator is kind of the actor for that character that you see, and that's why animators are cast into roles, because animators have it, they know how to do certain motions.
Absolutely.
Yeah.
So any big movie, any big, like a Pixar or a DreamWorks movie, an animator is assigned to that character because of their personality and their behavior. It is casting.
So, we've been we, like other companies, I'm not going to say this is a unique thing, I have been experimenting with systems like Move.ai where, we say, okay, well, let's record some scratch audio and let's just capture mocap while we're at it. This is not an original idea. This was actually done with the guys in lab coats before. It was also done in a more casual fashion by ILM when they made the movie Rango. They basically had a bunch of reference video
Yes.
cameras looking at the actors, and they basically did something akin to a pretty loose table read in a room. And that's why if you actually ever watch the animated movie Rango, it has a really kind of unique vibe.
One of my favorite movies
Yeah.
of all time. Yeah.
Yeah, and it's partly from that fact that they were all in the room kind of just riffing off each other.
I mean, again, the insight here is incredible. This is a great Friday to be at work. And then in terms of, there's the ease of use as one thing, right? The discrete nature of having a markerless system means that the actors don't really have to pay attention to it, or the animators don't have to pay attention to it. But for instance, for things like sports IP, and again, to your point around having baseball stars in and the amount of cost it gets even to have talent in studio, to do something that you can see here on the left-hand side for things, something like, and this is an actual person kicking a soccer ball, we aren't allowed to show the original video, but in terms of this setup and that would be required for that in a traditional context, what would the time constraints, the expense you'd have to go to try and get something achievable? This is straight out the pipeline as well, by the way. That's raw data that's gone through.
Yeah, so I could talk. So this looks like a motion builder screen grab left, and it's probably like a Lionel Messi, Ronaldo level athlete, my guess. So their time, that's cost one. And then the cost of the mocap operator, the stage itself, and then what you're not seeing is for every second of data here, you're looking at hours and hours of cleanup, hand cleanup to get this all dialed in.
And then in terms of what we talked about right now is a process that is using video that uploads to the cloud, that goes, you capture video, you upload to the cloud, all of the pipeline that I described runs automatically, then spits back out those animation files. That workflow has been in existence probably for about 3 years now. In terms of like
it's terrifyingly simple for mocap. For people who've worked in mocap before, this is like, I can't even believe this actually works.
I remember
honestly.
when we first spoke and you were like, when we first spoke and Ria was like, so I've now got like a mocap lab on my table. And people don't really believe me that that's what it is.
I know, it's like a little box. I've got a little box and it says leave open when charging the phones, right? And it's got 6 iPhones in it, and that's my mocap setup. And my friends who've worked in mocap said before, it's like it used to be that when we set up the mocap system, we had to like plug in an unbelievable number of cables and look at sync and all these things. And I said, now it's mostly we have to log in. We have to type logins on each phone. That's about it.
We're going to get rid of that, just see.
Please, that's, yeah.
But what we found as well is that throughout our journey through motion capture's business and getting feedback from people in the room, people on the stage, there is also, as we all know, a need for motion capture live, right? Every system outputs motion capture data live, and an optical system does it, inertial does it, and an RGB AI system should be at the same level. So what we at Move.ai did was we'll go, well, this should be feasible, but how do we actually do it, right? And I'm looking at Anas in the crowd because he's the one who's done a lot of the legwork on this, so thanks very much, mate. But what we did was we took and we optimized, with the help of our friends at NVIDIA, the neural network. So the complicated artificial intelligence bit I described can run quite heavy. Like running a convolutional neural network is, by its nature, convolutional, right? It's big. So we had to do a lot of optimization to run on a local GPU that could run on-site, in situ, and stream live video through into a live production scenario. And what we have been fortunate enough to do is partner with Disguise to bring this product to market into realization. So what you see is on the left-hand side, our product that's called Invisible, because you can't see it and it has to be explained. But fundamentally, you have a number of discrete small RGB cameras around a stage. They are then streaming video into a server that's running that artificial intelligence in less than a third of a second and spitting that data out into the Disguise ecosystem.
Yeah, so a little bit background on Disguise, just for context. We make a platform that controls LED volumes. We have some of the biggest volumes that are powered by Disguise. So on the right there, that's our UI, and it's controlling the wall, the panel, the camera calibration, the camera tracking, the lens calibration, spatial calibration, color profile. All those tidbits that you don't want to have to worry about, Disguise is handling. On top of that, now you're getting a live avatar right into Disguise, and then that's being rendered in all the beauty and glory of Unreal Engine.
So
I just want to say it is, I'm going to sound like an old person now, or an older person, because I've worked with Mocap for so long, but it's hard to describe how amazing this is. Look at the Mocap cameras up in the ceiling. You see how they have little like rings around them? And why you wear the markers on your body? It's to improve the signal to noise ratio. It's to remove the distraction. The only thing these cameras see are dots in the room, right? And that's how you kind of work your way back to creating Mocap, just from dots, because you couldn't deal with any data more than that in the past, right? That's your computers were not powerful enough. Now you've got cameras processing full images, finding the people in them and processing them. I mean, the amount of compute power that we have available to do this is incredible. But what's more incredible is that people have put it together into the system that actually makes it easier for you to do this stuff.
It's productized, right? It's not a science project. It's something that you could run like you're running.
Yeah. Except for the live version, you do have to have those guys in the lab coats a little bit.
Anas, what's the latency right now? Yeah, 100 milliseconds. We launched it in April. It was about 200. We've halved it since then. So, the more we throttle the compute power, the more it comes down. But Addy, do you want to talk?
Yeah.
Us through
This is an actual product that you buy today to have real-time mocap on a volume, right? So you can literally write a check to the skies, and this is what you get, and it works just like that. So definitely
That was
right.
a check.
I see some check writers in the audience. So we have in the center of it, we have our VX server, which is the heart and core of our system. It's doing the compositing and the pixel mapping and all those complicated math algorithms is happening in the middle. On the left, we have our render cluster. So that's connected over 100 gigabyte fiber network. And that's running Unreal at incredibly high resolution and frame rate. And then that very top box there, the MX Move, that's just running the real-time solution for Move.ai. And guess what? All those things are working at incredibly low latency, hundreds of thousands of times a second to update itself. And then the end result is LED volume. You get mocap.
And earlier today, this whole conference is about virtual production and LED volumes and things like that. And a lot of the discussion in LED volumes is like, well, we're trying to make sure that this part of the system knows about that. Look at the amount of knowledge this system is processing in real time out of the state of the stage. And the idea of combining this with an LED stage, I mean, that is an incredible, that's an incredible amount of information to make available to your process.
Yeah, the sum of parts is greater, right?
Exactly, and that's what through partnering together on that and actually building that workflow together, when you actually realize the sum of those parts and people walk on a stage and go, oh shit.
Oh fuck.
Yeah. And to that point, in terms of the use cases we can spin out of this, it doesn't, and I think from my perspective, coming actually from a broadcast background initially, a lot of virtual production techniques have been in existence in broadcast for a long time as well. And what you can see is actually things such as a real bugbear for LED floors is shadows, right? Just automatically cast a shadow relative to talent movement.
Walk us through, Niall, how under the hood you guys were casting that shadow.
Yeah, so basically what happens is we have a number of cameras around a stage, right? Let's say 4 cameras will track a single person on a single box. We can go up to 8 cameras will track 2 people in about 30 feet by 30 feet volume. Then all that data gets streamed into the invisible software, then gets spat out as a data feed into Disguise. What you then have is the character actually being driven in Unreal Engine and being rendered.
A metahuman.
Right? It's a metahuman, right? Yeah. But what we do is we actually remove the actual mesh and we cast the shadow down onto the floor. So what you can then do is actually utilize the lighting within Unreal and also link that to your lighting in Studio and have that accurately depict and reflect where you want that shadow to be, which ultimately gives you, for things irrespective of broadcast, it just brings depth to life for production.
Yeah, again, real-time information that the system is extracting off of what's happening on set, as opposed to, as was mentioned earlier, all this static info. Like people always saying, well, like Paul mentioned in the previous session, it's like that, everything we put on the screen in the virtual stage is static. Because it has to be for optimization purposes. But when you have a system like this that is dynamically looking at the stage and calculating what's moving, now you have a whole new layer of useful information that lets you do things like move lights around, move people around, and react to that.
And also move objects as well, right?
Yeah, exactly. So in this case, you're seeing that the particle system in Unreal is being affected by the person on stage. So this is a glimpse of what I call human to machine interfacing that becomes a lot easier because you've just now significantly reduced the barrier.
And it doesn't have to be limited to the studio either, right? Like imagine if you are walking into any of the many theme parks that are in this part of the world, and you're able to then go into an experience and interact with that. So you can see on the left-hand side here, you can actually see this person's arm is driving the torch that lights into the cave. On the right-hand side, my left. Got completely thrown by my left and right there for a second. You can then have interactions relative to physics.
I mean, like a Disney theme park ride or something. Now you have this audience interacted with the digital environment.
Yeah, because I mean, previously to have this kind of interaction, you'd have to put something on somebody's wrist or something like that. But now if the cameras can be 30 feet away and they're just looking into the room, you can actually see where the people are without...
And multiple people.
And multiple, yeah, exactly. And there's no, it's a low barrier to entry, an easy sort of, user interface to interact with.
Exactly. So it brings that experience level up without necessarily having to do anything. That sort of the awe and wonder of actually being at a theme park, for instance, can be.
Yeah, and the implementation in Unreal is actually super straightforward. Yeah. Like if as an Unreal artist, you're not, really doing rocket science. You're just adding a bone or a tracker to an existing light in this case. So now you have all this data to feed off of.
And this is the kind of thing that we used to do on set. It would upset the lighting department no end, but we would do this on set. Like I don't know if you guys ever saw the movie Monster House years ago. Really great film movie, animated movie. Thank you. Worked on that. One of the movies in one of the scenes in the Monster House, they're going around with flashlights and everything. And we did that on set and we put so much effort into it and everything. And it was amazing that we saw it kind of in real time, not a super high quality version, but the idea that, you don't even need any markers. You can do the same thing now on set casually. It's just kind of mind-blowing.
Monster House was a Spielberg project.
No, that was well, indirectly. I think it was, yeah.
Great movie.
Sort of goes into the next point, and actually as part of the virtual production workflow, where what our belief is that human motion can apply across all of these different pipelines, right? These different use cases. But from both of your perspectives as experts and leaders, particularly in the virtual production field, with advances for things such as Markerless for the rendering techniques that are now available, where do you see use cases both today and where do you think it could go in terms of applying Markerless within a workflow, in a virtual production workflow?
I mean, any scene, any kind of you look at any movie nowadays, like a really good example, and I did not work on any of these movies, just to be really clear, but Marvel, for instance, when they did Iron Man and things like that, they would not wear a full Iron Man suit because, of course, even the best made suit like that would be very restrictive and uncomfortable and hot. So, they would wear like a helmet or something and have a couple of markers or something, and then the rest of it all would be added in post. I mean, now you can kind of work with this directly on set. You can say, well, if we move some lights on set here and it's reacting on the actor's face, and now we can actually see it real time on the suit,
Yeah, exactly. And with Disguise XR technology, it's all augmented and composited in real time. So you have a digital avatar as close to final as you can.
Or you could do it like at a pop-up, in Christmas, something like in a shopping mall.
Yes, absolutely.
Exactly. Like you turn up and be like, get your kids to come in and be Iron Man, right? Like, I mean, Disney already sort of do that on some of on their cruise ships, right? So like the application of that, bringing that, well, I think your point as well, right? It brings the overall time of the pipeline down as well, right?
Yeah. When something becomes really easy, then you start to find new ways to use it.
Or another use. I mean, this has been kind of done in a different form, but this is all sort of as it goes down and down into the marketplace. You have things like people trying on clothes in stores and things like that. But that's a very mundane use and probably doesn't need something anyway.
There's a huge market for digital fashion.
Yeah.
Absolutely.
100%. And while we're here, and there's a lot of chatter around it, there's a lot of talk around sort of what generative AI can mean, and I think in an animation context, and so you were saying earlier about animators wanting to be actors, but a lot of the time animators spend a lot of their time.
They are actors.
But they also spend a lot of their time doing repetitive things, right? Repetitive animation. So one thing that we're looking at is like how can generative, for instance, allow those actor animators to do more creative, more freedom creatively, but actually do some of the more day-to-day stuff more automatically.
Right. How do you free up their time to do the cool stuff?
Exactly, and that's the stuff they want to be doing, right?
Yeah.
So, where we have actually, this is a world first prototype that you're going to see in a second, but I wanted to just go into like a wider view around that. This I really like, and this is something that's actually in a Fortune article around how AI is understood and how generative AI can be understood. And it's being picked up in a lot of different ways, right? So you have a lot of conceptual leaders, let's say, who are just talking a lot of waffle around AI. You've got a lot of enthusiasts using it.
It's an English word, awful.
You got a lot of enthusiasts, and you got people that are very cautious around it, and people, I'd probably put myself in the sort of pragmatic realm around AI. But what I find really interesting in the middle of this is that the curious creative lands right in the middle of this Venn diagram. And two things. One, I want to get both your perspectives on that before I show some behind the scenes things in terms of how curious creatives have been up to. But what do you think in terms of, there's a lot of talk around AI, but actually, do you think that the creative community actually could be one of the biggest beneficiaries of it if they can combine the conception of enthusiasm, caution, and pragmatism?
Yeah, I mean, absolutely. I think that you see management talking about AI sort of creating things whole cloth, and I don't think it'll ever work that way, because one of the hardest things with AI is to kind of pin down a very specific vision or a very specific example of something. It's possible, but you're still very often compromising, and I'm sure AI will get better at that. But the thing is that what's fascinating is to look on YouTube and see the workflow processes that artists are using it for, where they'll find a character like in an image generation program. They'll make like 3 or 4 views of it, and then they'll take that image and they'll snap it onto a generic mesh in Blender, and then they'll create a character face from that, and then they'll work with it from there and add, like dynamic hair and everything else. I think that where it's going to be really interesting to see how artists, as you're saying, in effect are using it to improve their workflows and make them, let them explore spaces more quickly. So they could, for instance, generate a proxy or a rough character very quickly like that. It might not be a final, but they could find somebody to be fairly close. The other side of that, of course, is artists have to get ready to be inundated with a bunch of AI images created by producers for their storyboards. And that has good and bad implications.
Yeah, and all of a sudden the producer's giving you the entire storyboard of the film. It's like, go make this.
Yeah, like these 20 images, but different.
Yes. So for me, the big AI use case is taking a lot of the tedious tasks and just making them disappear.
For instance, imagine having the ability to just type a prompt into a system and say, give me a person crawling.
Yes. So I could tell you to mocap that would be probably half a day, a whole day of work. To animate that would probably be a week of work.
So this is fundamentally what we've done. This is a proper prototype. This is basically a generative AI database that allows you to actually take a motion data and actually prompt it to do things. The other one of these was give me a person walking around drunk, which we didn't do, but fundamentally.
Yeah, and the interesting thing here is notice the floor contact between the torso and the knees and the feet, and how those are not penetrating the floor. That's really important. There's some serious IK solve going on here, and it's recognizing the floor. So this is very sophisticated data.
I have to say something about floors, because they're more sophisticated than people think. It's like when I've done mocap, like one of the things that you find is that, of course, a lot of the mocap systems traditionally are really like mathematically accurate. You say this is 0 and everything else is 0. But then you actually sit down and you say, well, I'm capturing in this building. This is built in 1968, and it's settled quite a bit since then. Then you find out that that end of the room is 11 centimeters higher than this end of the room. And if you're trying to do floor contact,
Right.
it's like you better be 11 centimeters higher over there.
Floors are incredibly complicated. I think a customer of ours recently was doing a capture shoot on a very large volume that's a sports field. And they didn't actually anticipate that in their game, their sports field is flat. There's no such thing as a flat sports field because they have to be curved for drainage, right? So actually there was like a meter differential between the center of the pitch and the corner.
Yeah, it's huge. It's like I worked on a stage once and I found out it had a hump in the middle, and they said like, oh yeah, 3 years ago we had a water main that broke under this stage. So,
Sure.
Yeah, I see that.
So yeah, floor contact is particularly hard. As I say, this is very much a prototype that is sort of sat in the back end of what Move.ai is doing at the minute. But it sort of gives you a bit of a glimpse into the future of how you could do things like animate background characters and, you know, scene characters where you need your actors to be doing the important job in the middle of the stage in front of the camera, whereas you need to do crowd scenes, you need to do
Exactly.
thousands of generic animations where you can actually take what is captured data and reuse that in an effective way to make that quicker.
And this could also be the base layer of animation. So an animator can start with this crawling data and then add their touches, their artistic vision on top of this.
Yeah, or as we saw in a few other sessions, editing, motion editing, with text. Or I could say, like, I'm going to do something that looks like crawling. Or I say, make it more like a lizard.
Right.
Right? It could become part of retargeting. Yeah. It's just an amazing space that really is not yet very explored.
Exactly. And I think there's, you know, Addy did a great session earlier around looking at nerfs. And I think, like, ultimately you can see future Addy where you can start to combine to create iterative concepts quickly around, you know, creating a 3D scene, applying character animation through it to start to at least get you to a pre-production phase, potentially, right?
100%. Again, you want to reduce the total number of hours you work on something, take the tedious task away, and spend those valuable hours on the stuff that matters.
Absolutely. So that's in terms of, we're going to move on to Q&A in a second, but what I wanted to do is just have a sort of a quick glimpse both into the future and outside of media entertainment, as we often can get stuck in our own bubble. And actually, human movement is everywhere. It's fundamental to the way we live, right? And what we're seeing is a lot of different use cases for things like motion capture in things such as coaching, right? Imagine trying to we were talking about this at lunch, teaching your kids to do a free throw, take a free kick, pitch a ball, catch a ball.
Yeah, one of the biggest markets for motion capture was actually in golf training for quite a while.
Yep, Roger Dunn used to sell these golf club simulators.
And if you then don't do your golf swing properly, you're going to need physio. And ultimately, you know, actually remote healthcare and things like physio are like going to be taken massively off due to advances that will be made in motion capture. I think the technologies that have been developed initially for biomechanics and adopted by media and entertainment are actually now fleshing back into the market.
Yeah, like in biomechanics, for instance, one of the things they did is you'd have like a runway that the doctor would ask you to walk down, and that runway actually had what were called strike plates, so that they could find out when your heel struck the ground and when was the point of maximum weight transfer and things like that.
Absolutely.
All as part of, basically rehabilitation.
Yeah. Now we see NFL teams actually using a combination of motion capture and force plates to look at things like injury recovery, right? If your gait and or your load-bearing capacity has changed after an injury, that massively depends on how you then train going forward, which is actually part of and into things like safety, right? So for industrial safety, actually some of the motion capture companies in the room, a lot of their business is industrial, right? Making sure that people and objects move safely around facilities.
Yeah, like for instance, the systems are so easy to bring to facilities now that you say, okay, lift this box, and you'll say, well, you didn't do it in a way that kept your back under the least stress, and that is a huge issue for most businesses. That where people move boxes around.
Or auto manufacturing plant where you're moving heavy things every day. Yeah.
And heavy things are moving around you as well.
Right.
So you have to have safe human movement around that.
Just recognizing where a person is in space and then the robot moving the object around it.
And on the other end of it, UPS drivers are actually trained to step out of their vehicle in a particular way so that they reduce the amount of impact that their foot has on the ground when they get out. Yeah, all kind. I mean, like you think that's crazy, but they do it like 500 times a day, sometimes carrying heavy boxes.
Yeah, and the deployment is as simple as a camera.
That's the thing, right? Is that when you get down to things like, and it will not necessarily for the highest end for things like episodic film, where you need lots of frames, lots of resolution to get that really high fidelity motion, where you can say point a single camera at someone doing a repetitive motion constantly, you can then start to actually do things like simulate what they're doing. Like I was speaking to a company the other day who are looking at simulating training on oil rigs, right? A very dangerous environment. If you can actually allow someone to move freely around a virtual environment, which is essentially a virtual production technique in itself using VR.
It's location scouting.
Exactly, right? What they're doing is their location, but what they're avoiding is explosions. and ultimately, like...
You lose. Oh, sorry.
Yeah. So the idea is then is to utilize their movement to just repeat that muscle memory to then ultimately be able to guide themselves more freely around a particular scenario environment. So it's interesting, I think, what we can see is that there are going to be wider uses of mocap techniques, especially markerless mocap techniques, much far beyond where we are in a studio today.
Right. Yeah. Because of the lower barrier, now we're going to just see a massive proliferation for mocap everywhere. 100%.
Yeah, I'll just say oil rigs are multidimensionally terrifying.
Aren't they just? So on that note, I would like to thank everyone for joining today. Thanks for joining us in your post-lunch slumber as well.
Thank you.
And thank you both to Ria and Addy for joining. Like, your insight and the almanac of motion capture here is absolutely insightful. It's been excellent. We're gonna open up to the audience.
It's called nerd.
Gonna open up to the audience for questions.
Can I ask a question while I'm slowly walking over? How does this compare to like Sony's Mocap or,
It's a
sort of-
different offering, right? Like, fundamentally, we're not asking you to wear anything. But that's that out of the box thing. Price point wise, actually, we have an offering that's very similar to that, but it uses a single iPhone, right? So you have to pump your iPhone down, which you have in your pocket, and then you pay, let's say, $5 a month, and then you get that. So one, it's cheaper, and two, it's still high quality.
Yeah. And the Mocap data, to be honest, is not as good as Move.ai data. So I think that's just a different use case.
Yeah, but
great.
again, there are going to be some uses where it'll actually work for them. And because it doesn't cost somebody anything, they'll use it.
And that's his point. There is scope for both, right?
Great. Did you have a question?
Hi, I'm going to push back a little bit and ask, so how does this, because you say you're using kind of AI and algorithmics to solve for the skeleton, so you're still on some level using kind of a generic, not generic, but like a uniform mathematical equation to help solve for the visuals that you see in front of you to translate into the mocap data. Is there a level of specificity that is individual to that person's performance that gets lost by using kind of by using this technology? For instance, for the hyperextended people, that sort of stuff, but also just the really nuances of we were talking about someone who has one leg slightly shorter than them, and so that radically and very specifically affects their gait cycle in a way that if you solve using a universal, this is the universal template of human movement, that gets lost in translation quite literally.
So actually, it doesn't.
Okay, cool.
So basically, like, yes, we've trained the model on like a huge variation of different body types and different movement types. And actually what the model does is, yes, it uses to Addy's point earlier, a general humanoid model. But what it does is it actually accurately represents your bone lengths. So relative to your joint positions, which are unique, for instance, to you, it would know my left thigh is shorter than my right. And that data would actually be applied actually probably more accurately than it would be if you did a generic solve, which we don't do. So actually the bone length estimation is actually pretty unique to that individual, and you can profile that to that person as well if you wanted to.
It's not assumed to be symmetric.
Yeah, exactly.
Oh. Hey, Addy.
Hey, Marcus.
Thank you for this. My name is Marcus, ex-Disguise, currently...
His nemesis appears.
Yeah, exactly. Resident Syndicate. We mentioned latency earlier, and say that you're down to approximately 100 milliseconds.
Yep.
How far can you push that, and what is the current bottleneck? Is it GPU processing? Is it solved by multi-GPUs? Is it a network bandwidth thing? Can we ever get down to like sub-frame latencies at 60?
I'm going to say yes.
Yeah, I mean, like, depends how much you throw at it, right? Yeah. One thing there's a couple of things we're doing. One is like higher frame rates are ultimately the higher the frame rate you go, like the lower latency you can get. That's why like some of these cameras here run up to sometimes 1,000, around 240 FPS. The challenge with that is when you're running RGB video, that's a big pipe to process, right? So like what we actually try and do is two things. One is actually compress video, but then uncompress it when we need to. So they are like on the fly doing that. And as you say, as things like CUDA cores advance and GPUs get even stronger for things like inference, that's when we can utilize that. But that's only one part of the pipeline.
I just want to add, yeah, exactly. So the majority of the delay is not going to be your mocap system, and this is historically true. It's going to be a real-time rendering system. So Unreal is going to get better and faster, and I think the bigger savings is going to come from your renderer rather than your solver.
Yeah, I mean, traditionally in virtual set systems, most of the latency actually came from getting the camera output, right? Like if you look at an Arri camera, you're at least 2 frames behind reality, if not 7 or more. And the weirdest thing about those cameras is that if you like turn synchronization on, which you usually want, so you get frame lock and phase lock, the the latency goes up, which is like really mind blowing. But you know, it kind of makes sense in something. The other problem is that if you crank up your frame rates to like 240 frames per second, you need a lot more light in the room too, because now you only have a 240th of a second to produce an exposure on your imager. So there's, you know, it's just, you know, just the latency knob can be turned down, but just as you do it, your credit card gets more and more expensive charges to it. That's kind of.
Yeah, so I recommend using machine vision cameras. I believe you guys use FLIR.
We use FLIR. I mean, we're
Yeah.
pretty agnostic. We use FLIR right now because it's quite cost effective and actually gets us quite a lot of what we need. But, you know, bigger megapixels will get you better quality. And again, a bigger pipe out the back of the camera. If you use an SFP out, you're going to get faster data, right? So we're trying to get it, to your point around the cost, we're trying to get it to a cost level that is approachable to the market, but still maintain the latency and quality that's acceptable.
Yeah, and I mean, mentioning IR camera, you know, FLR, if you use infrared also, of course, all of these cameras, one of the tricks that they use to improve signal to noise ratio for all those little dots they're looking for is that they all have infrared strobes. And those strobes operate, you know, flash really short period of time, very brightly, and that's what the retroflector is giving you back. In this case, you don't have that, but you could still, again, around a specialized camera, you could still use strobe lighting in the room.
Yeah.
And I think we were joking and saying that the optical cameras that we have in this room could be perfect for Move.ai.
Yeah, exactly. We just take the IR.
Yeah, they're just built for it.
As long as they run RGB at the back, some of them don't, some of them run grayscale. But
Right.
There's a question there.
Yeah, I had 2 questions. The
Go on.
first was doing these suitless video capture. Do you guys have any protections in place with your platform for performer consent?
So if people want to opt out, they can. That's ultimately like, but ultimately there's 2 answers to that. One is the system doesn't actually care who you are. It looks for a human being. It doesn't recognize who you are. Now, if you are performing as part of a production, like the production and how they handle the performance data is down to them. Ultimately, anything that goes into the Move.ai system, depending on the production, depending on the IP, depending on the contract we put in place with the person, is that the performer's rights aren't delegated by us. And also a lot of the actual IP owners, so this is a conversation we've had, their IP has to sit on their infrastructure. So we're pretty agnostic to that. If it was a user of ours, specifically to only the Move.ai platform, and they said, particularly because we're formerly European, but we still governed by GDPR. If you said remove my data, we have to do it, or give me my data, we have to do it. But if it's sort of in a production scale, it depends. The production company then handles the data and owns it themselves.
Okay, and then my other question was if you could give me a rough idea of your fee structure for running live versus doing post-processing on videos after the fact.
So real time is completely different, and depending on the size of the volume you want to capture, number of people, it can scale from like tens of thousands to hundreds of thousands. The post-processing stuff is very much depending on the workflow you want to achieve. You could do a single camera iPhone solution that will get you like a nice TikTok dance that you could do something with, but maybe you wouldn't use in production. That can then again scale and post-processing. If you wanted to do, let's say, 12 to 20 cameras running at 4K or 8K, 120 to 75 FPS is going to cost you hundreds of thousands, because that costs a lot to process. And ultimately, the IP holder who wants to do that wants that on their private cloud, which is not a cheap thing to deploy. So it scales at each end of the market.
Yeah, but I mean, there's a tremendous sweet spot just using 6 iPhones in a ring around a space, and they're just performing in there. And
Totally.
That would be on a subscription basis.
And if you sign up, you get a bunch of free. It goes by the minute, and you get like some free time up front, so you can like fiddle with it.
Yeah, you get like basically on the iPhone option, which is completely offline, runs in minutes to process and nowhere near real time. But that's running at like $30 a month. They'll get you like 6 hours of animation a year, which is a lot.
Yep, right there. Sorry, I didn't mean to steal you there. Piggybacking off of your question a little bit is, so like typing in a crawl, and you're like, oh, that'll take a half day and a week of an animator's time. I know people that can do that a lot faster, and it not take a week of animation time, and we can bust that mocap out in like 20 minutes. So my question is, obviously we know what the current strike situation and a lot of AI talk. when you're typing in something like that and it's coming up that crawl, how is it creating that crawl? Is it scraping the internet for something like that it's been trained on?
Not scraping the internet. It's looking at our database. So
Sorry?
it's looking at our database of motion that's been fed into our model. So if people go into like non-IP segmentation, they give us the ability to actually build products on the back of the data that goes into it. That's part of the rights that we put in place. That's part of the EULA. So what that does is basically it runs into the model and goes, give me, based on these labeled scenarios, i.e. person on the floor, elbow going forward, etc. Then we categorize that as a crawl. And then it goes, give me an estimation of every time you think there's a crawl, and it will give you back a representation of that. So that is like an amalgamation of every crawl it's ever seen.
Gotcha. From your database.
Yes.
Copy. Thank you.
Right.
There's a
You want
Mark
more?
had a question back there.
You, Mark? Oh, yeah.
We are about to launch an API that can do any single camera that you like. That has to be right now static. But iPhone, we built because we've got a bunch of iOS developers in-house.
Super quick, hands and faces.
Yeah.
So fingers we can track in post. We will track them real time soon, but fingers is a very different model to the body because I'm going to do this weird little motion. There's a lot of bones in the hand. They're very small. It's a pixel problem, and they're very small. If your camera is up there and your hand is here, it's tiny.
Yeah, and the other thing too is that we used to sort of say that the complexity of an entire body motion capture equivalent
Right.
to the capture of one hand fully.
Yeah.
That's how, the hand is incredibly.
It's historically hard with optical too.
Yeah.
Like
You-
this is the hardest thing to
We
track.
tend to
for sure.
recommend using gloves alongside it just because they get you that data. And for the face, there are enough systems out there that do a
Yeah.
very good job of face.
Epic Games has an incredible facial capture app.
Yeah, we don't
Yeah.
need to circle the face at Move.ai.
The latest generation Monos gloves are really sweet.
Yes,
Um,
they are. Yeah.
There's a question in the back, really
Oh,
desperately.
okay. All right, go ahead. Stand up,
10 seconds.
desperate person, because I'm tired.
Yep. Mhm. Yeah. So the question was, and say yes or no, but is it a good enough baseline to get you animation data? Is that the question? Yeah. Is it?
It can be a good starting point. Our use of it is for previs, so we do not have very high quality constraints on it. I think that as you get into a situation where you say you want to do something post quality, I think at that point you have to make an evaluation for your specific purpose. Like for instance, if you're going to say, I have to do this for an A-list actor in front of on a stage where I'm spending $20,000 a minute or something, I am not going to tell you it's going to work for every situation. I'm going to tell you you absolutely must do an evaluation for your own purposes.
And that's where like the likes of some of our AAA gaming studios will actually use those higher frame rates and higher resolutions because they want to drop it straight into the post pipeline. So therefore having higher resolution, higher frame rate reduces the need for things like cleanup, but ultimately all mocap needs cleanup. So at the end of the day, it's
Yeah, I mean,
depends on your pipeline.
if you're paying millions of dollars for an A-list actor, you really need the team of people in white lab coats to make sure that you don't screw it up. And not only that, you need to have multiple ways of capturing it at the same time. So if one of the methods fails, you have a backup.
To our point earlier as to why there's space for all the technologies in the same place.
Yep. That's it. Thank you. Thank you, everyone.
Thanks.
Let's have a big hand, everybody. Wow, that was amazing. You guys sticking around? All right, so I know some of you had more questions, so you can head to the back of the theater. In the next 2 hours, we have 4 different demos, really great demos.